I'm Mr. Baranowski, and I want to give you some context on nuclear weapons and what they do. Why is it so important that we don't use them? Why is the Cold War defined by them? And why have we never used one since August 9th, 1945? Well, I've done plenty of research on this over the years, probably enough to put me on various watch lists, so if I disappear, that's why. But I do it for you, and so let's use this knowledge to talk about, well, what happens in a nuclear blast. So, we'll do this looking at the Baker test, which is from the atomic anti-atomic cannon, launched a nuclear weapon about the same yield as one used on Hiroshima, which was 15 kilotons. So, the bomb starts with a tremendous flash, a flash brighter than anything you can imagine, a flash big enough, bright enough to blind you. If you happen to be looking in the direction of a nuclear blast when it goes off, you will be blinded, at least temporary, sometimes permanently. If you're close enough to it, it can actually melt the retinas at the back of your eyeball, blinding you permanently. It is an extreme flash that will give you massive sunburns to any exposed skin that's facing the direction of that flash. Then comes the heat. The heat, which is a result of that flash, radiates out from the center of the blast, and it vaporizes instantly all water involved in anything. And anything that happens to be wood, which is a lot of water, begins to flash burn. And you'll get things that are, things like us, which are mostly made of water, will actually vaporize. In the nuclear blasts on Japan, there were people reduced to ash and shadows on a wall. It's really, really intense. That's followed by the shock wave itself. The shock wave is what does the physical damage, and it works its way out at the speed of sound, and you can see it so well defined there. That's what does the actual knocking things down. That you have an overpressure at about 200 miles per hour that comes and pushes and just knocks things out, working its way out from the epicenter of the blast. Then what you don't expect is a suction. As the mushroom cloud moves higher up into the sky, it needs to pull air in to replace the hot air that's rising. And so you get a suction that happens afterwards. Everything is pulled in back towards the blast. Though you can still see that shock wave radiating around. That's that ring that's expanding. And then what follows all of that is intense radiation. And if you're wondering how we got any of this footage, it's from people who were using far too little protection, and I'm sure that would haunt them later in life. But what does this actually do? What's the actual impact of this? Well, using a website called NukeMap, nuclearsecrecy.com, Alex Wellerstein put together a tool that helps us to understand what this would actually do. And if you Google NukeMap, you can do this to anywhere in the world and find out what the damage of a nuclear blast would be. Using our nation's capital, which is right nearby, you can see from an airburst, nuclear weapons are first usually blasted over top a city. That pressure wave comes down and does a lot more damage, not getting impacted by hills and valleys in the terrain. If it's blasted above a city, none of that matters. It works kind of like a shotgun blast downward into the ground. There's also a surface burst that would come afterwards. And a surface burst will send a lot bigger crater, a lot more dirt and debris up into the upper atmosphere. All of that dirt and debris is highly radioactive. Radiation clings to the dust and dirt, and that's carried by the winds, and you can see just how far that radiation would go from one blast by two bombs, one surface, one airburst in that diagram. Those are done by the Topol missile, which is currently in the Russian arsenal. This could happen tomorrow, for all we know. Let's talk about that radiation. Radiation gathers on dust and dirt, and what's happening is that the atoms are actually falling apart, and as they fall apart, neutrons are shooting out in all directions. This image here, this video, is of a cloud chamber where you can actually see those neutrons being launched in all directions. That's decay happening in real time. Otherwise, you don't see it, you don't feel it, you can't taste it. There's no way to sense it, but it's there. And those neutrons are actually punching holes in your DNA. And so when your cells go to reproduce and they look at that DNA, they read it, and they read what they see, holes and all, which means you get errors in cellular reproduction, you get things going wrong, and you get cancers is what forms. If you get a high enough dose, your cell membranes actually begin to fail, and you begin to bleed through your skin. No cuts required. You simply start to fall apart. Your flesh literally begins to fall apart on you. It is a highly painful and terrible way to die, and something that should never befall anyone. What happens also in an airburst done above a city is that you get an electromagnetic pulse, a high voltage wave of electricity that moves through the air, and it knocks out anything that is electronic in an instant. Everything is fried, from cell phones to light bulbs and everything in between. In one flash, we are back to the 1800s. No electricity anywhere. Everything fails. So if you're stuck in an elevator, you're not getting out. If you're trying to call home, you don't have that option. If you're trying to drive away, there's enough electronics in a car, any car, that all of that no longer functions. And so quite instantly, it's all dead. And one estimate said that if you detonated a nuclear bomb 100 miles above Iowa, you could knock out the entire continental U.S. with no electricity anywhere. The long-term effects of that radiation, it is lethal for days. It is dangerous for weeks. I'm sure you all are very tired of hearing about sheltering in place for 2 weeks. Well, imagine that if the air outside was deadly. That's the situation after a nuclear blast. It's what you're experiencing now, but you can't go outside and take a walk. You can't go anywhere. Not only with the death and destruction, but the radiation itself raining down on the dust like snow. It is deadly to even be outside. So they say to put as much concrete between you and the outside world as possible for at least 2 weeks. You have to shelter in place for 2 weeks. And even then, it will be problematic, and cancer rates will spike, and all sorts of terrible diseases that we can't even fathom happen because of this radiation. Conditions of organs failing that we don't expect. Thyroid cancers goes through the roof, and so on. They also estimated, as this went on, that with all the dust and dirt and debris thrown into the upper atmosphere, if you had even just a couple nuclear blasts, you can actually reduce how much sunlight gets to the Earth's surface. And if there were a nuclear war, a full-scale exchange, you could blot out the sun enough to drop temperatures on the Earth and start a small ice age. They call this nuclear winter. And not only is that bad for us trying to stay indoors and stay warm, but what relies on sun to grow? Plants. Our entire food chain begins to fail and fall apart. So you get massive famines and death on that scale from a nuclear blast. So even if you survive the explosions and the radiation, you're not going to survive the nuclear winter. You could kill the entire planet and all life could be wiped out. Now, when you talk nuclear weapons, the thing that is always thrown in is duck and cover. And if you ask most of your parents, all of your grandparents, if they were in the States, they definitely experienced this in high school. Duck and cover drills.
There was a turtle by the name of Bert, and Bert the turtle was very alert. When danger threatened him, he never got hurt. He knew just what to do. He ducked and covered, ducked and covered.
That might cause some flashbacks for some of your parents and grandparents. I did one in the first grade, and that's probably the last one last ones that were being done. So this is still pretty recent, but everyone saw this film. Everyone knew all about it, and we like to laugh about it now, but it actually does make some good points. And what they'll talk about most, if you talk to elders in your family, they'll tell you about hiding under your desk to survive a nuclear blast. Talking about this.
These children are practicing to duck and cover just as you do in your school. We all know the atomic bomb is very dangerous. Since it may be used against us, we must get ready for it, just as we are ready for many other dangers that are around us all the time.
Now, of course, a desk is not going to save you from a nuclear blast. If you're close enough, nothing is going to save you from a nuclear blast. It doesn't matter. But just like in an earthquake, you try and hide under a table or in a strong doorway, the desk is there to try and protect you from debris falling on you, from the building falling apart, from the drop ceiling tiles crumbling and falling on you. At least the desk will put something between you and it and hopefully save you some injury. There is a logic to it. It's not an amazing logic, but it's a logic, and it's one that was actually thought through. The scene that most people like to laugh at is this one, though.
Sundays, holidays, vacation time, we must be ready every day, all the time, to do the right thing if the atomic bomb explodes. Duck and cover. This family knows what to do, just as your own family should. They know that even a thin cloth helps protect them. Even a newspaper can save you from a bad burn. But the most important thing of all is to duck and cover yourself, especially where your clothes do not cover you.
Now, most people say that you're simply surrounding yourself with kindling, and they're not wrong. The idea there is to protect yourself from the flash. That flash will cause major sunburns to any exposed skin. So if you can get anything between the flash and the sensitive skin of the face and neck, you can save yourself some extreme burns. And if we're not dealing with your skin burns, then you can go and help other people who are worse off. So as silly as that looks, there actually is a logic to all of it. In all of this, it seems very illogical. What protects us is more of the bombs, that the bombs themselves save us from the bomb. And it's called mutually assured destruction. This is a key term and something you absolutely should know. Mutually assured destruction is what keeps us safe. The idea is that whoever shoots first dies second. Whoever launches their missiles first, the enemy is going to see that those missiles are coming, and they're going to launch everything they have. Even from submarines, there's a good 10 minutes you have between launch and when those go off. So there is time for your enemy to strike back. And if your enemy can strike back, then you shouldn't strike to start with. Because, yeah, okay, you might have inflicted the first impact, but you're not around to talk about the victory. You're destroyed as well. And so, by knowing that whoever shoots first dies second, that there are no winners in nuclear war, then you have deterrence. You are deterred. You are intimidated from using your bombs, knowing that the enemy can use theirs. And if you use yours, they will use theirs. So trying to defend against a nuclear war is actually the worst thing you can do. By setting up a missile defense, first off, how are you going to shoot down missiles? They're moving at hypersonic speeds, and you're having thousands of them come at you at once. It's not possible. Anyways, even if you could, your enemy looks at that and goes, why are you trying to defend yourself? Is that because you wanted the ability to hit us without us being able to hit you? By losing that mutual part of mutually assured destruction, you are causing a problem. And by playing defense, you're actually causing offense. And that's something that no one wants. So, in a weird, illogical step, it certainly goes against prevailing thought that the bomb is actually what protects us from the bomb. Mutually assured destruction has worked since 1949, and it's why we're still all here today, as you'll see through the rest of this.